Welcome to this tutorial on Wait Job, a crucial cmdlet in PowerShell's job management system. Wait Job allows you to pause script execution until background jobs complete. This is part of our PowerShell Jobs series, where we explore how to effectively manage asynchronous operations. Understanding when and how to wait for jobs is essential for building reliable scripts that depend on background task results. Wait Job is a cmdlet that pauses your script execution until one or more background jobs finish running. Think of it as a traffic light for your code. When you call Wait Job, your script stops and waits at that point until the specified jobs complete. This blocking behavior is critical for 3 reasons. First, it prevents your script from moving forward prematurely. Second, it ensures that job results are fully available before you try to retrieve them. Third, it provides synchronization for asynchronous operations, allowing you to coordinate multiple background tasks effectively. Let's look at the basic syntax. First, you start a background job using start job with a script block. In this example, we're running getProcess as a background job and storing the job object in a variable called job. Next, we use wait job with the job parameter, passing in our job variable. At this point, the script execution pauses. PowerShell will not proceed to the next line until this job completes. Once the job finishes, the script continues. This simple pattern ensures your script waits for the background work to complete before moving forward. Wait Job offers several parameters for different scenarios. The job parameter accepts a job object and tells Wait Job which specific job to wait for. The timeout parameter is measured in seconds and sets a maximum wait time. If the job doesn't complete within this time frame, Wait Job stops waiting and your script continues. The id parameter lets you wait for jobs using their numerical identifiers instead of job objects. Finally, the name parameter allows you to wait for jobs by their assigned names. These parameters give you flexibility in how you reference and control your waiting behavior. Here's a practical example using the timeout parameter. We start a job that sleeps for 120 seconds, simulating a long-running task. Then we call Wait Job with a timeout of 30 seconds. This means we'll wait a maximum of 30 seconds for the job to complete. The result is stored in a variable. If the job completes within 30 seconds, the result variable contains the job object. If 30 seconds pass and the job is still running, result will be null. We then check this with an if-else statement. If result has a value, we know the job completed. If it's null, the job is still running after our timeout expired. This pattern prevents your script from waiting indefinitely. Let's review the key points. Wait Job pauses script execution until your background jobs complete, providing essential synchronization. Always use the timeout parameter when there's a risk of jobs running longer than expected. This prevents your script from hanging indefinitely. Wait Job is essential for synchronizing asynchronous workflows, especially when later steps depend on job results. Finally, remember to always check the job state after a timeout expires to determine whether the job actually completed or if you need to handle the still running job appropriately. With these concepts, you can effectively manage job completion in your PowerShell scripts.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.